All right. If I may, I think the first thing I have to do is close down the interesting conversations you're having. So good afternoon, everyone. My name is Adam Frank. I am an astronomer, an astrophysicist, an astrobiologist, as well as a writer, and I also do work in philosophy. And I am very happy to be one of the winners of the inaugural essay contest. And so today I just want to tell you a little bit about what was in my essay, the themes of my essay, because it leads to what's coming, the very interesting next panel we're having. And it's all about planets. Planetary is about planets. So what is a planet? Planets are nature's way of doing something interesting with sunlight, right? I could call it, we could call planets an engine or a machine, but that's the wrong metaphor. Because really, the fundamental thing about the planetaries, it's a fundamentally new vision of nature, okay? So we can think of them as planets are processes that introduce creativity and innovation into the universe. Because if all you had were just the regular laws of physics, that's not going to happen, right? It's what planets allow life to occur, and life is the engine of innovation. So here's the interesting thing about planets. When I was in graduate school in 1988, there were no other planets other than the ones in our solar system. It was a 2,500-year-old question that had not been answered. And then in 1995, we found the first exoplanet orbiting another star. And now we're at the point where we know about so many planets that I can say with certainty that every star you see in the sky has a family of worlds orbiting it. And if you count up 5 of those stars, one of them has an Earth-like planet in an Earth-like orbit where life might have started. That was one of what I call the 3 revolutions in astrobiology. Astrobiology is the study of life in its astronomical context, and it's a field that really didn't exist 30 years ago. And now we're at the point where we know so much that in the next 10 to 30 years, I'm pretty confident in saying that we will actually have data that will tell us something about the existence of life beyond Earth. I can't tell you what it's going to say. It could tell us that life is rare, but we're finally, after 2,500 years of asking this question, going to have data. So these revolutions in astrobiology, particularly one that's important, is looking at the long 4 billion year history of life and the Earth, life and the planet Earth evolving together, is that we've learned important things, and the most important things we've learned is co-evolution. The Gaia hypothesis was brought up before, and I have to tell you, the Gaia hypothesis has not been forgotten. It's actually an essential part of the endeavor of astrobiology. The recognition that life is not some green scruff hiding on the surface of a planet. Instead, going back to Vladimir Vernadsky, the great Russian biogeophysicist who coined the term biosphere, life is a geophysical force that can hijack a planet and reshape its evolution. That's the understanding that we have gotten from these revolutions in astrobiology. And if you want an example of that, take a deep breath. Smell that oxygen? You can't smell it, but enjoying that oxygen was given to you by life. About 2.5 billion years ago, a new form of photosynthesis was invented by life that took water, broke it apart, used the hydrogen to make a sugar, and then farted out the oxygen. And it changed. There was no oxygen in the Earth's atmosphere originally. 0. There was life, once life had formed, but there was no oxygen. The life put the oxygen into the Earth's atmosphere. And life changed the chemistry of a planet. Sound familiar? It's kind of what we're doing right now, right? So coevolution is exemplified by what we call the Great Oxidation Event, this thing that happened when life put oxygen into the atmosphere. And what it shows us is something really important, is that in the history of life and the planet, there's stages. Originally, the biosphere was what we might call immature. It was too thin on the ground to really affect the geospheres, affect the geological aspects of the planet. But then by developing networks of feedback between the planet and the life, or the life with itself, slowly the biosphere was able to grab hold of the rest of the planet and begin directing, in a sense, the planet's evolution. So the biosphere went from a point of being immature to being mature. That is the path of Gaia. That is the Gaian path. And in doing so, it created something that is essential for life, which is to become autopoietic. This is a term that Francisco, the great Chilean yeah, let's hear it for Varela, who will get his due, is already starting to get his due, but will get his due in the planetary. So autopoiesis is to be self-creating and self-maintaining. It is the essential character of life, to be an agent and to have autonomy. And to become a mature biosphere, any planet that has a biosphere must become autopoietic. Now, planets can do something else. They can create technospheres. That's what we've been doing for the last 100 years. And what we see with the technosphere is that the technosphere is not mature, right? What we've created so far is an immature technosphere because it is actually destroying the conditions that it requires to exist, to have continued existence. It is not autopoietic. So what this exoplanet revolution, what astrobiology gives us, is a vision that any planet on which life occurs, if that life is going to endure for geologic timescales, tens of thousands, hundreds of millions of years, it has to go from becoming immature to mature, meaning autopoietic. And autopoietic also means it develops a kind of intelligence, a kind of knowing and response. So to become a mature biosphere was the beginning of the origin of planetary intelligence. To become a mature technosphere, which is the goal of the planetary, we have to develop a new kind of planetary intelligence. And so that is really the foundation for the discussions that you're going to see here. The idea that the exoplanetary and the exohuman forms the basis, the necessary basis for actually bringing the planetary to fruition. And this is going to be a long project. It's like building cathedrals. It's going to be a project that will take, a century or so. But the discovery of exoplanets was actually not an accident that it happened at the same time that we faced the climate crisis. It was a necessary co-evolution. Thank you very much.